So I gotta tell you though, I am extremely impressed with all of you and proofs. I mean, seriously, it's yes, I understand they are tedious, they are long, they are
not fun,
easy. But you know what? It's like all of the things that I'm saying, and then all of a sudden I go and I grade them, and it's like, yep, got it, got it, got it, got it, got it. So either the world's greatest cheating expedition is taking place, and like one kid in the class gets it, or like you guys are really rocking it. So I think you guys are really rocking it. I don't think the whole cheating thing is. Who knows? Oh my God. Yeah. All right. Now here's kind of the good news. So there is that Schoology assignment that is due tonight, 11:59. If you didn't get it done, get it done. Here's the good news, though. That is all that I would be assigning you for the weekend.
Oh my goodness! Thank you.
So, but yeah, I don't really have anything planned. So here's good. We have today, Monday and Tuesday, to do two days worth of lessons in 3 days. So guess what? We're gonna leave here, no homework tonight. Leave here with no homework Tuesday night, and that's kind of where we're rolling. Monday, that might be a little something, but just maybe a smidge. So, all right. So we're starting at 5.1. If you have your geometry tools bust out, develop an understanding of the definition of a triangle's medians and how that they apply in proof. All right. So, sweet. Look at that. We get to go onto the internet. Here we go. These should be exciting.
I got it. I got it. I think I misplaced those along the way.
Okay. Well, borrow somebody's next. Ready?
Two for.
I have to show you something else.
Okay. Is it the video?
No, it's a picture of Ruby. It's really
All right. So, medians of a triangle. The medians of a triangle. The median is the middle, somehow. And so, drag the orange dot. Dragging the orange dot. Okay, I don't know why this is supposed to be cool, but I'm dragging the orange dot. Okay. So the medians of a triangle is the line segment from the vertex of the triangle to the midpoint of the side opposite. Okay, so if I were to take and find the halfway point of this segment and put a dot, and then take that dot and go right to the vertex and do that on each side, notice they all converge into the center. Because the three vertices, this is of course possible medians. Fascinating things about them is no matter what the shape is, well, they will always intersect at a single point, and that happens to be called the centroid, okay, of the triangle. Now, let me tell you some information about the centroid. The centroid, yeah, what? No, I'm good, thanks. The centroid is, in the world of physics, called the center of mass, okay? So what would happen is if I were to have this object, no matter how I make it, if I put my finger right here and was able to balance it, that would be the exact balancing point, no matter how I move this around. Okay? So the centroid is called, it's the center of mass. Here is where center of mass works out in the outside world. Porsche 911 Carrera, when they came out with the twin turbo bad boy back in the early 90s, because of the shape of the car and how all of the angles converge at the center of mass, the center of mass of the Porsche 911 Carrera twin turbo was 9 feet underground. Their claim was it was impossible to flip this car over by going around a corner. Think about that. Now, that doesn't mean the car wouldn't slide in the direction it's trying to go, but the car itself would not flip over. I just saying what they had stated. I have no idea if it was true or not. I was never able to take a car like that and go around a corner that quickly to see if I get the wheels off the ground.
What happened after
The Porsche 911. Porsche.
I thought you were
Porsche. No. Not the Twin Tower stuff. No, this was the Porsche 911 Carrera. The one that kind of like a bubble looking thing. 9 feet underground. I mean, do you think that's good for a sports car industry to say, you can't flip this car?
Yes.
Now I will tell you all this. My dad, God, I love the guy. So my dad, many years ago, bought a boat. And I don't know if you all know boats, but the boat that he bought was called a Boston Whaler. That was the brand. Okay? Now, Boston Whaler's boat has all types of things that they can advertise. One, if you were to cut the hull in half, both sides would still float. Not quite sure why you needed to know that information. Boston Whaler also said, you can't flip our boats over. And there was one time that my dad had the boat out at Chatfield. And it was a real windy day and huge waves as far as a reservoir should have. And my dad's like, it's my dad and I, and he's like, come on, let's see if we can flip it. I was frightened for the first time with my father ever. I'm like, Dad, I'm 40. I don't want to die. He goes, no, look, you can't flip it. I mean, the props coming out of the water. I'm like, he's like, I'm like, Dad. Hold on, my feet are up in the air like this, hanging out. Dad. See, told you couldn't flip it. So the moral of the story is, don't ride in a boat with my dad. He will frighten you. So, but the centroid, center of mass, is where all of the medians, the middle point to the vertices on a triangle, all three of them will meet. This happens on any shape. So if you take this out to the world of three dimension, that's how Porsche 911 claims. The Porsche 911 car claims that it would not flip over. Good information or useless? I don't care. Take it however you want.
Useless.
Okay, so the median. So the median of any shape would cut this and this into equal parts. And then I would take my, from here, back. Okay, that's how I find the median of any side. The centroid would be where all of the median parts would happen to meet. So the centroid, center of mass, it means something. It's something that does apply out there. Okay, think about it. If you were to really work with anything with physics, the center of mass might mean an awful lot. There's similarities between the segments for all three different triangles. Okay, so there are similarities between the segments for all three different triangles. So I guess we're talking about three different triangles related to the legs. Okay. Which of these following statements would always be true? All triangles have three medians. I can cut each side in half, yes? So that would be true. A median bisects the angle it passes through. So if it bisects the angle, what do you think that means? What do you think it means by the angle? Does it cut the angle into two equal parts?
Oh wait, no.
So if I were to cut the segment in half, do you think that line coming back to the angle would cut the angle in half?
Yes. Actually, yes.
Exactly in half?
Yes.
Okay, so let's put a question mark there. We'll discover if that does or does not take place. A median divides one side into two congruent segments. Yeah. Okay, if I have this length of this side and I find the middle of that, this segment and this segment are equal to each other. So yeah, that works. I like that. The medians of a triangle intersect in a point in the interior of a triangle. As far as this goes, it seems like, yes, it's going to work. But I just want to point out that the center of mass does not have to be within the object. You want to know why a boomerang works? The center of mass is outside of it. So when you throw a boomerang, it's going around, but it's not going around its center of mass. The object doesn't have a center of mass that's actually part of the object. The center of mass is outside of it. So what it's doing is it's going to go around its thing. That's why a boomerang, when thrown correctly, will come right back to you. So the median's in a triangle, so I think the important part here is triangle. So yes, I think that would work. The medians are perpendicular to the side that they intersect. No, they don't have to be. So that's a no. And I will tell you this one is not always true as well. Okay? So the median, when I cut the side in half, that point will go back to the angle. It does not necessarily have to cut that angle into two equal parts as well.
No way.
Okay?
Phil, why I didn't see
It's
that.
Phil. Phil's out of control, but you know, hey. Okay, so we're going to do this construction, but I'm going to work through it with you all. Okay? So, if done correctly, all three medians should intersect. So if you have your compasses, awesome. Okay? So, let's talk about how we might find the middle of a segment using a compass. And measuring is not the term I'm going to be looking for. So if I were to have my compass out, how would I find the very center of, let's say, the segment AB? Any ideas? I can't measure. I'm only using my compass. We might have done a little bit of this. What I'm going to do is this. My first thing I'm going to do is I'm going to open up my compass. Okay. As long as the compass is open to be a little bit wider than halfway or more of the segment we're talking about, we should be able to find the midpoint of it. So,
Oh, can't you do that perpendicular thing?
watch this. Ready?
Or whatever
Let me do this. You with me?
Yeah.
Okay. Don't do it on yours yet. I'm going to flip my thing over.
No, I see what you're doing.
And bring this down here.
And then they intersect.
Okay. How many points did I just create because of swinging my arcs? More than halfway. 2. If it was only halfway, our intersection of arcs would take place right here in this very center, which that's not going to help us. But if I were to now take a straight edge, bust out Mr. Ruler, where'd it go? There we go. Ruler. There we go. So I'm taking my straight edge. And let's see. Gotta help me out. I can't remember. There we go. That works. There. Okay. And sing along if you know the song I'm humming. Oh shoot.
It's the hard knock life. It's the hard knock life for us. Blah 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 blah.
Okay.
I don't know the rest of the words.
All right. If I were to draw this line, I'm just going to draw right here.
Nice.
Okay? Everyone with me?
Yeah.
Okay. Ruler, go hide way for a bit. Okay? You can just watch and then it's recorded, so if you want to do it. All right, so something I'm going to do is I'm going to now erase the compass swung arcs. Is that okay? Never mind. I am not going to erase. It's not gonna. I don't want.
Okay, you try.
I tried. That's all that counts.
X.
Where?
X. Top.
Where?
Tried
Top.
so hard
Thanks.
and got so far.
Okay. Sweet. Who said that? X. Thank you, Johnny, or whomever. All right. So. Next one. So I'm going to keep that little Jim Dandy there. That's my little. This is halfway in between A and B. That's the midpoint of it. And what I'm eventually going to do is I'm going to draw from this point down to C. But I'm going to hold off until I get the rest of my construction done. Okay? So let's change colors of our pen to purple. Okay? So I'm going to measure the distance out of A to C. So if I was going to do this appropriately, I need to have my compass open to be slightly wider than halfway. Would you feel that's slightly more than halfway? Is that okay? And I'm just going to swing an arc, and I'll get rid of those arcs in a little bit. So I'm going to do that. Flip him over. Bring you up. Okay. 2 more points are established. If I find the distance in between those, and I'll just use this. I'm going to use my straight edge here to. Does that seem all right? Cool? Yep. That was easy. Go back to my compass. We'll do this one in green. Bring this down. I just need to have my distance open to be a little bit wider. Is that a little bit wider than halfway on the B to C? Yep, I'm going to swing an arc. Okay, bring this over. Let's flip it over. And we'll bring this back this way. Swing it. And use my straight edge on that too. Okay. So, the points that I'm going to worry about, this point here, I'm going to connect, I'm going to call this point C prime. The reason I'm going to call that C prime is because it's opposite from angle C. Does that make sense?
Yep.
Okay. This point right here, what am I going to call this point?
A prime.
A prime because it's opposite of what?
A.
A. Okay. And this point is going to be B prime because it's opposite of angle B. Is that okay so far? All right. Let's pick a color that's obnoxious.
Yellow.
I'll go with orange. But I'm actually going to change that to this. Over there. Call that. Let's go more colors. More colors. Oh, I'm going with purple today. All right, ready? So from point A, I'm going to go to A prime. Still with me?
You got this. Don't mess up. Nice.
From B prime, where am I going to? Point B. From C prime, I'm going to point C. Good. Can everyone see that all of the pink lines are intersecting? So right there is the centroid. The centroid is where the middles of each side, the medians of each side, to their appropriate angle will intersect. It's the center of mass. If I was to cut that triangle off the board, which would make a mess, but if I were, I could balance it on my finger right there, and that is the center of mass.
Can I try that?
Might make a mess. But, so your bottle flipping events that you fellas love. I heard I heard that there's a survey on Facebook that you can fill out on this survey so that the bottle flipping will make it to the Olympics. I heard that.
That's so dope. That's so sick.
And as long as I said it, it must be true. So yeah. So again, America for the gold for flipping bottles over. What do you do out of this? I'll probably go back to math class.
Dude.
What do you think?
Yo, Sawyer.
All right. So things about our finding. Things about our finding. With our center of mass, with our centroid, there's also a relationship from how far the center of mass is from its vertice to its center. Okay? So, if I were to have this and this, my 2 points, I'm going to call my centroid C, or actually go centroid, because I already have a point C, sorry. So, from A to centroid, from A to centroid, from centroid to A prime. So A is the angle, the vertex. A prime is the center. We good saying that?
Yeah.
This is 2/3 the distance. This is 1/3 the distance. So if I were to say that line segment from A to A prime was a distance of 9, from A to centroid would be 6, from centroid to A prime would be 3. Let me say that one more time. If I were to say I knew that this distance here, let's say I knew this distance here is 30. Still with me? That was a distance of 30 inches or whatever. The distance from here to here is 2/3 of 30, which is 20. This is 1/3 of 30, which is 10. And it works every time, and it works here too. It's the same relationship, yeah. Yes. Yeah. Yeah.
Is it always going to be 2/3
Uh-huh. As far as the centroid goes, every time. Doesn't matter which one. So that's kind of a big key to recognize. Okay? Can we chill for a few more minutes? Are we okay? Okay, another way to review this relationship is 1, 2, 3. The shortest line. Uh-oh. What do we got here? Gotta pull these things out. Okay. The shortest length from the midpoint to the centroid. The longest length from the vertex to the centroid. The total length is the entire length. Okay? So again, that is going to be where that whole center of mass takes place. The reason why that center of mass takes place, it's not on accident. And this is where geometry really starts becoming a beautiful thing, because things are happening in geometry on purpose, and they are consistent with things outside the real world. Any of you ever go on a sailboat?
Yes.
Or you've seen a sailboat?
Yes.
What is the big boom that comes straight down the bottom of a sailboat called? No, not the one that goes up with the sail. What's the other one called? Stern. I don't think you're right. Yep. Not the poop deck. I like it though. So on a sailboat, I want you to think about this. So let's pretend I can draw really well. Here's my boat. Still with me? And now we have this sail. Still with me? Is that okay? Let's just pretend I know what I'm doing, okay? All right, so what we're going to do down here is we have something that comes down like this. Underneath, it's not an anchor.
Got the triangle.
What's it called?
The motor's on it, the back motor, tiny motor.
It's not a motor. It is.
Oh my god! Is it the thing that makes it turn?
No. Here's the rudder back here. Dagger board? Okay, so here's the boat. What do you think this down here? It's a massive weight, is what it is. What do you think? It's not an anchor though. It's not. This is you. If you do not have this, if you just have the sailboat like that, what do you think is going to happen to the sailboat? It's going to tip over in the water. What do you think this is going to do? It creates ballast underneath, which creates the center of mass of the sailboat happening underwater. So when the sail is pushing, that is all. Yeah. Dagger board? Okay, that's okay. I'll go with that. 2 people said it, and I like it. Yeah.
I got the triangle.
Outside of the, you're saying, the porch, center of gravity 9 feet below. Would that be considered attached to it or not?
That is attached to it. The center of mass of the Porsche is not attached to it because that means it would be going through the road. Right? So, this is to take the center of mass of the boat from like here, and the lot further down and heavier that is, the further down that center of mass of that boat's going to become. The further down that center of mass, obviously if this goes down 15 feet into the water, you better be in deeper water than 15 feet. Okay? Or if it hits something, and it's very possible. And I'll tell you what, if that did hit something and it snapped off, and you were in a good wind, your boat is out of control. It is going to tip over. There is really nothing that you can do other than bring your sails down going, shoot.
Yeah, that's
Call
what
it.
I'm saying.
That's official sea term, shoot. If you want to know anything about sailing, I strongly urge you to talk to Mr. DeGaitis. He's Matthew.
Hey!
He's awesome.
He
He is like a sailing fanatic. I don't know if y'all know that, but his summer job for many years was go get really rich people's yachts from like the Bahamas and sail it up to Maine. It's like, man, really?
I love Mr. DeGardi.
Yeah, he's a great guy. I love that guy. So, okay. If D is the centroid, we know that AE and EC are the same, yes?
Yep.
We would know if G, that would CG and BG would be the same, yes? We would know that FB and FA are the same, right? Because we're cutting each thing in half. You see where a proof might come into this. Just talking proof. All right, so let's think if we can talk about this. From here to here, this length right here is a total of 12. Okay? So this length right here is 2/3 of the distance. This right down here is 1/3 of the distance. What do you think?
6.
6? So would you feel that from B to E should be a distance of 18? Because would 2/3 of 18 be 12?
Yeah.
Yes. And that would mean that this distance here would be a distance of 6. I like it. Okay, and again, this takes place over and over in math for a reason. Okay? Find DE and BE. Find DE and BE. We got it. We're done. We got it. All right. So, I'm going to call us good here. We will finish the rest of this on Monday.
I got the triangle.